Let's see if we can advance some slides. All right, good morning. Welcome to our webinar, Putting Precision Irrigation to Work for You. We're going to cover this morning some introductions, and I'll provide those introductions to the team members that are going to present today. We're going to have a little bit of a conversation with regard to what precision irrigation is, at least from the viewpoint of WaterBit, and then talk about precision irrigation in action. And then at the end, we will answer questions. We'll try to get through as many as we can, and hopefully address whatever items you might want to bring to our attention. Quick housekeeping. Everybody is on listen only, but you can ask questions. There is a question button in the upper right hand corner, and if you click on that, you can submit questions. We'll be able to see those questions, and then we'll be able to answer those at the end of the webinar. So don't hesitate to throw a question in there if there's something that you're interested in hearing. Really quickly, some introductions. My name is Leif Chastain. I'm the COO and co-founder of WaterBit, and my role in the company is leadership on the sales and marketing side, as well as most of the operational roles within the company. I try to spend as much of my time out and about with growers as I can, but I'm really not the expert that's going to be talking today. Instead, we've lined up Bob Coates, who's our product director and a principal design engineer at WaterBit, and Sebastian Brahm, who's our agronomist and a PhD in soil science. And both of Bob and Sebastian will be providing the majority of the webinar today. I get the wonderful opportunity just to do a quick introduction. So let's dive into the content. So what do we mean by precision irrigation? It really comes down to the right amount of water at the right place at the right time. Everything in a field is dictated by the soil water holding capacity, the crop that's being grown, the time of the year, and the agronomic state of the crop. And so all of those elements come together with other constraints from the farm, of course, and decisions are made with regard to when and where to put water on. Our view of the world is that using in-field data from sensors and from other inputs and applications, combined with the ability to automatically control valves, gives us an opportunity to improve on what's been, a practice that's been honed over, hundreds of years now at this point. But at the end of the day, the real goal is really truly as simple as just getting the right amount of water at the right place at the right time. The approach that WaterBit takes is based largely on control theory, the idea that you can create a plan, you can determine what it is that you want to do using, again, a variety of inputs. You can come up with that schedule, and then executing that schedule, sending that schedule in an automated fashion to the valves, where the electronics and the equipment automatically do what the plan, execute the plan as it was defined. The next step is once you've done that, you need to make sure that what happened is what you expected to happen. That the valves were open, that the water flowed into the fields, and as well looking at what's happening in the field itself, from the amount of water that was applied, what its impact was in the field, what the change was in the soil profile, etc. And then based on that data, bringing that information back into the system, refining that plan, making adjustments, and then moving forward from there. And there's two sets of capability that enable us to do that: hardware, field hardware, and communications of the field that Bob will speak to at length. And then the cloud application side, where information is gathered, analyzed, plans are made, schedules are created, and it's sort of the portion of the application where we monitor and control what's happening in the field. What are the benefits of precision irrigation? And this is always a wonderful debate, but the benefits fall into a number of categories, and to be honest, depending on what it is that you grow, what the scale of your operation is, and what the problems that you're facing, some of these may or may not really be all that relevant to you. The very first one I'll start with is kind of right in the middle of the page on the financial side. One of the things that's happening, and I think everyone who produces a crop is facing, is changes in labor law, changes to the regulatory environment, and that's creating uncertainty and issues that are not your day-to-day growing, normal problems that you have. Dealing with the cost when you've got long irrigation cycles and that sort of thing can be very, very challenging. And so one of the initial benefits that we see from automation is just an opportunity to be able to model and control the costs of operating and running irrigation as an agronomic function across your farm. If you can save water as part of that, there's obviously opportunity to save financially on the cost of water and the cost to move and pump water, energy reduction. All of those have the potential to yield a bottom line cost reduction. There's also the potential for agronomic benefit. A lot of the work that we've done in the vineyard space is really focused on trying to reduce variability. And by reducing variability, there's an opportunity to create consistency across fields and therefore generate or create a situation where you have greater economic benefit available to you. Putting the right water on at the right time helps with the health of the plants. Healthy plants being more disease resistant and or preventing situations within the fields where the irrigation practices might create incremental disease pressure just based on how the water is being applied. For example, long sets overnight where it may create issues with humidity or creating an environment where disease vectors flourish. And then the final one, of course, is environmental, and probably the most important from an environmental perspective has to do with just making sure that the nutrients that you put through your irrigation system are in the root zone and available to the plant and not being flushed through. And I think that's probably the first and foremost. But dealing with salt issues, and then ultimately also just having a record of what you did, what you put on, how long you ran your irrigation system for, to be able to comply with SGMA and the other regulatory schemes that are in play right now are all helpful areas where automation can play a role on your farm. So with that, I think I'd like to turn it over to Bob, who is going to take you through the meat of the presentation.
Thank you, Leif. First, I just want to thank everybody for joining us today. I hope that everyone is doing well with the shelter in place and that you're all healthy and able to continue operations during this difficult time. So I'm going to talk to you some more specifically about some of the features of our system and how you can utilize it in your ranches, in your farming operations. So what are the different aspects of WaterBit's precision irrigation solution? You spend a lot of labor, money, and energy, not to mention the water itself, for controlling irrigation. WaterBit's smart irrigation solution is designed to let you apply the right amount of water in the right place by being precise, meaning that you can control and automate irrigation at a field, a block, or even what we call a microblock level. A microblock being our term for a sub-block, a smaller increment area based on your growing needs that help you precisely deliver water where it's needed most and in the right amounts. WaterBit also allows you to be mobile. So you can control your irrigation, you can view your data using your phone, your tablet, your computer, wherever you may be, you can have access to the WaterBit ecosystem to manage your irrigation so that you don't have to drive to the field to toggle valves every time, verify irrigation pressure in the system, check soil moisture, things of that nature. It's irrigation monitoring and control at your fingertips. WaterBit is designed to be simple. The solution itself is solar powered. There's no batteries, meaning that it's virtually maintenance free. It's small in size, so it doesn't get in the way of your work crews or machinery. For example, in vineyards, mechanical harvesters have passed right over the top of WaterBit equipment that's in the row, and you haven't had to remove it at all. So that's a huge advantage in terms of the size and ability of our system to operate in those environments, is that it makes it simple for the grower. You don't have to worry about it once it's installed. And WaterBit is powerful. I'd like to kind of say that it helps you feel more powerful too. Data is available 24/7, again, at your fingertips. It's mobile, but it's there to help you make more data-informed irrigation decisions, and also to provide data records that help you streamline your reporting and your planning. If I can get it to go to the next slide here. Here we go. So the goal of WaterBit is to provide a complete solution, from monitoring to communication to and from the farm, automation of those capabilities, and analyzing and reporting the data. So I'll talk about it more, but the WaterBit Carbon is kind of the backbone of our on-farm telemetry network. Has a long-range radio that lets you communicate between all of your sensor and control devices over the internet through our WaterBit Connect gateway. And then we can automate all of those operations in terms of valve control, scheduling. We also have something with a closed loop block irrigation control. So if you set up a block valve controller from WaterBit and you have soil moisture sensors, we can actually set thresholds at your desired depth to maintain a certain moisture content at that depth, with the goal of trying to make sure, again, like Leif mentioned, put the right amount of water in the right place at the right time. So you're not under irrigating, you're getting the water, you're putting water on long enough to get it right into your root zone. You're not putting it on so long that it's leaching unnecessarily, if it's for nutrient purposes, or if you do need to leach salts, that you can make sure you are in fact leaching them below the root zone. For normal irrigation, you can set up a closed loop irrigation schedule for our block valve controllers that will automatically maintain the level of moisture at the depth that you need it. And last, analyze and report. I've mentioned this already. You can download your irrigation history. This could be used to generate reports for compliance or tracking purposes for future irrigation needs. But the goal is to be a complete solution for automating and controlling irrigation on the farm. I'm gonna have to try the other method to click here. There we go. So the carbon. This is the brains behind the WaterBit solution. It's our core kind of proprietary technology. And what's special about it is the amount of kind of tech that has gone into this box. Ultimately, growers don't want to be worried about the tech. You just want to know that it works. And that's part of why, it looks very simple from the outside. And it's designed to be compact and simple from the outside, and we take care of all the complexity on the inside. The device is solar powered. On the top there's a solar panel that's about the size of your thumb. It's in what we call an IoT, or an Internet of Things device, meaning that it'll operate over the internet through a cellular connection on our gateway. And it is easy to install in just a few minutes. Oops, somebody's clicking there. Easy to install in minutes, and it's available 24/7. As I mentioned before, there are no batteries. It works in very low light conditions. Most of our systems are installed under canopies, for example, in wine grapes, in the row, monitoring soil moisture sensors or controlling valves. And so because there are no batteries, you don't have to worry about replacing batteries, every few years when they finally, the chemicals degrade in them and they are no longer able to keep the capacity that you need to operate the system. It utilizes a sub-gigahertz long-range radio over LoRa, if some of you have heard of that, which is gives you very long range, mile range from each of the carbons to the gateway, depending on the particular conditions on your ranch. but that's over that radio that you send and receive commands. We have standardized connectors, so you can't see it on the bottom of the carbon there, but there are a couple of connectors onto which you can just plug in WaterBit sensors and actuators. And everything else is integrated into the box for radio communication, logging, and interfacing with the sensors. So it's compact, quick to install, and is designed to run 24/7 without any kind of intervention. So to give you kind of a picture of what this looks like, on an example ranch, we start off with installing the WaterBit carbons, which are going to monitor the devices and control the devices on the ranch. So you could install the WaterBit main valve controllers and block valve controllers to allow remote control and automation of your hydraulically actuated valves. You can install the WaterBit soil moisture sensors, which again, that's kind of the verification part of things to allow you to monitor that the valves are turning on and off at the correct times, that your water pressure is within spec for your drip or your other irrigation system, especially when you are controlling many different blocks or microblocks simultaneously. You can monitor soil moisture sensors so that you can verify that the water is again reaching the right depth, i.e. your root zone, that you have your desired moisture level so that you can control your leaching and your irrigation and optimize everything right where it needs to be. Also, you see that we have the MicroBlock valve, which is in the middle of our little vineyard here. And that's something special that WaterBit offers to really provide the level of precision that many growers are finding they'd like to adopt in order to better manage their crop on a site-specific basis and optimize a number of different factors. And we'll talk more about that in the next slide. But altogether, all these different devices that we're monitoring and controlling communicate through the WaterBit carbon over the long-range radio to our WaterBit Connect gateway, which has a cellular backhaul to the internet where we store all your data in the cloud, as we call it, on an internet server, and you can access it remotely over the WaterBit dashboard, which is our software product for accessing the maps of the device locations and charts and data, and the controls for actuating your valves and scheduling irrigation to happen in an automated fashion. And then you'll see the little orange box at the bottom of our pump there, and it says pump control coming soon. We do have pump control, which has been an oft-requested feature addition, and we're very excited to roll that out with some of our beta customers coming this year. So you'll hear more about that as soon as it's generally available. And so I mentioned that the MicroBlock valve is something special that WaterBit creates that's kind of unheard of in the industry in general, in terms of the level of irrigation management that you can enable with this technology. The goal is to provide flexible, precise water delivery at a sub-block level. So you can have smaller, well-defined management zones that are based on the design that are going to meet your in-field variability needs or constraints. So it could be due to differences in soil texture, differences in vigor of the vines, yield or quality variation, any number of different factors. And those differences can be grouped into areas within a block that we call a microblock. And using the WaterBit MicroBlock valves, we can actually install those. You see in the little diagram down here, you actually install those on each of your, in this case, drip lines. And each MicroBlock valve controls irrigation to two different sides. So that would be to the drip line going into each of two different microblocks. So with the little diagram we have here, you'll see that we're controlling irrigation to 4 separate microblocks using a MicroBlock valve between every 2 microblocks. And in the photo here, you can actually see the MicroBlock valves and the carbons installed in a vineyard. The goal of all of this, of course, is to try to improve your water usage, your crop quality, reducing leaching and runoff, improving your management of vigor across a block that otherwise it would be treated uniformly, and hopefully also achieve water savings. And a few slides from now, we'll also talk a little bit more about MicroBlocks at some sites in our deployment spotlights that Sebastian will talk about. And so some of those are pretty exciting. So, how can you leverage your existing infrastructure? WaterBit doesn't anticipate that we are the end-all be-all of all on-farm technology. There's a lot of great companies out there that we work alongside and work with. And, the goal is for us to be able to allow customers to leverage all of their existing investments to improve farm management. So, WaterBit does integrate with technologies like AquaCheck and Centex soil moisture probes, and will continue to add new partners that come along to add value to our portfolio and make it a more all-in-one solution. However, if you have sensors out there that are monitoring weather or ET, sap flow, plant available water, things of that nature, that bring you value in your irrigation or your farm management decision making, you can still use all of that information in terms of how you're going to plan out your irrigation and plug that into the WaterBit platform in terms of the schedule that you want to have, or the closed loop irrigation that you want to enable, so that you can utilize data from your other sensors in order to make the decision, and then plug that into the WaterBit system to automate your irrigation. Have it run at the time when it's off-peak energy use, or when you don't have reliable labor available, or you want to irrigate more frequently and for smaller amounts. And again, you don't want to send the guy out to turn the valve on and off repeatedly. You can create a schedule to do that for you remotely and automatically. In terms of the irrigation infrastructure itself, the WaterBit valve controllers can operate with most hydraulically controlled valves, and the MicroBlock valves themselves can be used on existing drip lines. So WaterBit is a partner you can rely on. We provide the hardware in the field and the software that allows you to have the networking communication, the monitoring, and the control that you need 24/7 at your fingertips from your mobile devices. We provide support and maintenance in terms of being able to upgrade your system as needed, in-field support if there are any problems. We have a field crew that's usually on site within 24 hours for anything egregious. And of course, we provide the cloud services for managing your data, making sure it's backed up and available to you wherever you are and whenever you need it. We also have API integration, for example, for those who are more sophisticated and need to remotely access their data. That's available as well. So with that, I'd like to introduce Sebastian, who will talk to you about some of our fantastic deployment spotlights.
Thank you, Bob. So you've heard about precision in time and in irrigation duration, or in irrigation amount. I think I'm going to talk a little bit more about spatial precision. And I have 3 examples that I'll be talking about, or 3 crop examples: wine grapes, tree nuts, and berries. And there'll be 2 examples for wine grapes for different spatial resolutions. So let's dive right into those. It's not advancing. Come on. Who has their pointer on the control there? Okay, so WaterBit Spotlight wine grapes. This is the first. No, now we're too far. Back one. Okay. Ooh.
Sorry, it's you know, WaterBit's good at technology, but operating a slideshow over over the network sometimes hangs everybody up. You got it there, Sebastian?
I'm trying to.
The delay kind of mixes it up sometimes.
Okay, here we go. So that was you. There's a considerable lag here.
Yeah.
Okay, we had that.
Everybody's on the internet right now. There you go.
Apparently. Here we go. So the first example in wine grapes is where a grower knew that they had inherent soil variability and therefore water availability to their grapes. And they wanted to create a vineyard where they get very uniform grape quality and grape yields. And their way to doing this was to cut up this vineyard into quarter-acre lots, and quarter-acre because that's the resolution of the remote sensing technology they used to look at NDVI to gauge the vigor of the vines. And so we gave them the option of, with the WaterBit MicroBlock valve, to actually irrigate each of these quarter-acre pixels individually. So they look at the ET data for that vineyard, but then they modify the irrigation for each of those quarter-acre pixels by looking at the vine vigor based on satellite data, which comes at a quarter-acre resolution. And so far, this system has worked very well for them. And they are excited that they are, in fact, able to control irrigation this precisely on a quarter-acre scale. The vineyard is not quite in full production yet, but the goal, as I said, is to make sure that the vineyard pretty much matures, the fruit matures uniformly throughout this vineyard, and that the yield and the quality are also more uniform, so that the overall predictability of the quality and therefore the value for the grapes goes up. The second example is very different based on how the decisions were made to carve up the vineyard into management zones. And this is a flagship vineyard in Napa Valley, very high value fruit, but because it wasn't ripped properly, there is significant difference in access to water for these vines. And therefore they get quite a wide variety of vigor in this vineyard, of potential yield, and the fruit quality and the ripening also differs. Some just keep growing and ripening is delayed, and some with uniform irrigation would ripen early, and if it had to be picked separately, otherwise you would lose the quality. So what the what the grower did is they sent their viticulturist and the winemaker through, and they did evaluation of plant vigor across the vineyard, row by row, and the winemaker was doing taste testing, and they combined that data and split the vineyard up into areas that are high vigor and low vigor, where they want to be able to provide more water in the low vigor areas and be able to throttle back the high vigor ones. They then handed that map to us. We looked at some remote sensing data and saw quite a good correlation there. And then out of that, we developed cutting this vineyard up into 31 management zones. So in this 13-acre vineyard, you can irrigate 31 different blocks completely individually. And you see the example there at the lower right corner, where the green lines represent where the MicroBlock valves are installed, and then going out from there, you see the different management zones. So with this technology now, the viticulturist is able to irrigate each of these blocks individually, and they are very excited about what this will do for future fruit quality. We also are deployed in almonds, and while this is not quite as crazy high value as the last example, this is a very profitable crop if done correctly. And the grower here at Schulz Ranches, he was not happy that he could not really validate what happened with his irrigation. When was it turned on? When was it turned off? He had to completely rely on his field hands there, and he wasn't sure if the irrigation was actually done the way he wanted it to, and he also had no idea what part of the soil profile he was really wetting. So we installed soil moisture sensing and also pressure sensing. So now he can validate when the irrigation is happening, how long it's happening, and he can see the effect of an irrigation. How, if I irrigate for this long, I get this penetration of moisture in the profile. And he found out that he actually had been leaching quite a bit, which of course not only costs him water, it also costs him nutrients. So he had a quite significant amount of water savings by not over irrigating anymore. He also saw a yield increase, which is not too unsurprising, because in almonds, they don't like wet feet. So if you saturate the root zone and keep them wet, it slows them down. It slows down nutrient uptake. They don't really enjoy that. Plus, you increase the risk for disease pressure. And he spends a lot less time irrigation scheduling because he can do it all on the user interface. And as a result of having to use less water because he is pumping, he also reduced the amount of electricity used to move that water. So overall, by being able to see what's going on in the soil in his orchard and what the actual irrigation events are and being able to schedule them precisely, that has helped him tremendously. And lastly, this is an example from berry culture in hoop houses. Again, they had no idea how deep they were wetting the soil underneath the canes, and because this is on the Central Coast, where labor is really scarce because it's basically impossible to hire new people to come in because the cost of living is so high there. They deployed our technology to have soil moisture sensing, and this is in the berry rows in the hoop houses, even when they're covered, and that allowed them to more precisely monitor their irrigation and not overwet the profile, keep the root zone moist, but not go beyond that. And that allowed them also to redeploy their scarce labor to other things where you cannot automate things, where you truly need a person that takes care of that product. And as a result of less fluctuation in the soil moisture, and therefore more consistent growth and less stress on the plants, they got more consistent fruit, which of course translates into more money for the grower. So this one, I think, is again the summary that Leif is going to talk to you about. I'd be happy to answer agronomic questions if you submit them.
Thanks, Sebastian. So we, of course, would love to talk to anybody who has an interest in meeting with Sebastian or Bob or myself, and to talk about a trial and if you're new to thinking about deploying precision irrigation on your farm, we'd love to have that conversation with you and understand the challenges that you face, how this technology may add value to what it is that you're trying to do and for what you're trying to achieve. And we're happy to meet and to try to help you understand how we can have a positive impact on your farm. If you give me just 1 second. So I think that brings us to the Q&A section. Before we do that, though, I'd love to thank everybody who's on the call, and I'd like to reiterate Bob's comments. This is a crazy time for everyone. I know that we're all most likely working from home at this point in time, and we certainly hope that everyone is safe and that everyone is getting through this what is unprecedented period of time. So thank you all very, very much. We've got a number of different questions, and I'd like to go through some of these. The first one I'd like to go through, I think, is a great question. It's what parameters should you consider while designing a precision irrigation system, and then how can good irrigation system design help with precision irrigation technique? I'm going to start on that, and then I think I'll let Bob and Sebastian put their thoughts in. Precision irrigation is really about, like I said, two major elements. It's dealing with the variability, the spatial variability in the field, and then the actual physical variability that just simply exists due to Mother Nature. If you're looking at putting in a new field, understanding the soils, the soil types, the water capacity should influence your physical design of your irrigation system. And if you're only looking, as an example, to deal with sand streaks or changes between lighter and heavier soils within a particular field, oftentimes you can address that just by taking what you might deploy in terms of a large block and breaking that up into smaller blocks in order to be able to control. And I know that in the past that's been a challenge to do just simply because of the increased labor and having to deal with increasing the valve count within any particular field. But I want to talk specifically about a different aspect of precision irrigation that I think that everybody should take into account. And it has nothing to do with technology or radios. It has to do with humans and human nature and change management. One of the biggest challenges that we see routinely when we look at these types of technologies is that while looking at it makes logical sense, it makes theoretical sense, and almost always makes financial sense, it's oftentimes when the system meets the field where the challenges really begin. And that's because bringing precision technologies into a field requires some changes in terms of farming practices. And so I would say that one of the other things to consider while designing and understanding how to deploy technology on your field is how you as an organization or as a grower are going to deal with bringing this technology in and aiding your own team members and your own organization in understanding how the technology brings benefit, why it brings benefit, and then helping your organization go through the change management that's needed. That would be kind of my 4.5 cents on that topic. I would open that question up to Bob and Sebastian. Do either of you guys have additional comments?
I'll just make a quick comment and then Sebastian can jump in. I spent over a decade doing ag research at UC Davis, and one of the big things that we always harp on is that good irrigation starts with a good irrigation system, not just dumping technology on top of it. So you should understand the performance of your system and the design to make sure that that's a well operating system. But even having said that, technology can provide a tool to help you in places understand where you have limitations in your system, and then help you either work around some of those limitations through changing the size of your blocks, or seeing where your soil moisture is, or seeing your irrigation pressure, and being able to manage your operation more effectively because you have more information about it than just kind of looking at the design itself or going out and manually running experiments. So, you know, irrigation design is important in terms of, you know, making sure you have good uniformity in a well operating system before you bolt on too much technology, though the technology itself can help in terms of really understanding your system. Sebastian, anything else there?
All right, I'm going to take that as a no. Okay, so moving on, we've got a couple of other questions. One of the questions is, and Bob, this is for you. What's the battery life for the carbon product? If the data is communicated twice a day using LoRa, we can say data is communicated every 15 minutes.
Yeah, so we right now all of the carbons report data every 15 minutes. So whether that's your soil moisture, your pressure, or the status of the valve that it's controlling, that's reported every 15 minutes. And as we mentioned before, there are no batteries. It stores energy another way, and then that is, and I'll kind of tie it in. I think there's another question I saw here too, but it's designed to send data every 15 minutes and run 24/7 with no problem. And the other question was, you know, if it rains for 7 or 8 days continuously, you know, what happens? And so the whole idea is that it operates 24/7. You know, we've had these units go through entire winters, granted in California, you know, and they stay alive doing their job. If you cover them in snow and have zero light, you know, that might be a problem. But you know, you're probably not doing too much farming at that point for most crops. But in any case, yeah, they're designed to work in very low light conditions with no batteries for, you know, year-round operation.
Thanks, Bob. Sebastian, I've got a question for you. The question is with regard to setting up microblocks. How do you make the decisions? How would you subdivide to determine how to create microblocks?
Well, this depends on the crop and on your goals for that crop, and also where you are. I mean, the beauty of our system is that we can make microblocks in existing orchards or vineyards. If the grower knows, for example, if the grower knows I have a sandy spot here that has very rapid infiltration but low water holding capacity, then we can isolate those areas, and he can implement, or she can implement, a schedule that would irrigate more frequently but for shorter durations of time, so that the water stays in the active root zone and doesn't just fall through. So that's one thing, depending on the soil. Another one is, as I mentioned in the first wine example, where growers look at the vigor that they see on remote sensing, and they want to bring up low vigor areas or depress high vigor areas, then we can split it out that way based on NDVI maps. And in order to do that, it's usually not good to just use a single picture during a single season, but a lot of the remote sensing companies have time series available, so you can look at multiple years, and it's usually fairly simple to identify spots that consistently have lower vigor from areas that have sufficient or really high vigor. So it really depends on which crop you're growing. Is it wine grapes, or is it almonds? Is it other tree crops? And that way, you know, based on the goals for your crop and for this, and based on the soil conditions, or, you know, ignoring the soil conditions, just looking at the crop vigor as it manifests, we can split things out. In wine grapes, for example, some growers want to bring the yield up uniformly. In very high quality wine grapes, a lot of growers want to not increase yield, but they want to have the vineyard ripen uniformly, so they don't have to send a hand crew through 2 or 3 times, but maybe actually can switch to machine harvesting only once and have the quality that they want. So it really it's a dialogue with the grower. What goals do you want to achieve, and what variability do you see, and do you need to manage?
Thanks, Sebastian. We've got time for a few more questions. If you have additional questions, be sure to submit those in the upper right-hand corner with a little question button. There's another question here, and I'll take a shot at answering it. I'm not 100% sure but I understand. But the question is, how do you manage with LoRa technology, and then the communication from the gateway? So, you know, one of the challenges with doing automation on farms is scale and the distances that you have to communicate. The topology that we've chosen from a deployment perspective is really designed to enable us to create what we refer to as a local area network over the farm. And that network is what provides the backbone for the communications to devices that are on the ground, the valves, sensor devices, actuators, anything that's deployed on the farm. That communication goes through LoRa to our gateway, and then the gateway communication is via cellular. It can also be through satellite, but it's primarily through cellular back to the cloud. And that's the topology that we've chosen for a variety of reasons to deploy on the farm. There's a question, Bob, for you. Do you use software to delineate the irrigation management zones?
Yeah, so the irrigation management zones can be defined in the software, you know, so that when you're viewing the WaterBit dashboard, you can see that if I'm controlling, for example, in the case of MicroBlocks, you know, I have a series of MicroBlock valves that are installed in the field. The system is plumbed a certain way so that when, you know, MicroBlock valve side A turns on for a bunch of these MicroBlock valves, that it irrigates one whole MicroBlock, and you can see that depicted as a boundary in the WaterBit dashboard, so you can see what's happening. So you have to plumb the system the right way, of course, but ultimately it is all defined in the software for ease of understanding what's happening while you're on the dashboard, if that makes sense.
Thanks, Bob. Next question is for Sebastian, and it's a 2-part question. I'm actually going to take 2 of these. The question is, how deep? Let me rephrase that. Sebastian and Bob, why don't you both take a shot? One thing I'd like to point out is that in addition to being our product manager, Bob also works extensively on research that's done in conjunction with the chairman of our board, and has spent a lot of time thinking about this next question and how to use soil probes and how to make decisions with those. So the question is, how deep do you recommend the soil probes to be buried? And I'm going to let both Sebastian and Bob speak to that a little bit. And I think maybe just more generally towards the use of soil moisture as an input to irrigation management.
Yeah, I mean, I'll give the high level answer, and then I'll let Sebastian maybe get a little more detailed on it. You know, at a high level, you know, the depth that you're going to monitor with a soil moisture sensor is really dependent on the crop that you're growing and the rooting depth of the crop and the depth at which you're trying to control irrigation. So I'd say that, you know, ideally you'd want to have sensors within the rooting zone of your crop so that you can see that you're getting the moisture, the water that you're delivering through irrigation, or the water that's occurring due to rain, that it's getting to the right area of the root zone for the plant to utilize it. But you might also want to monitor below the root zone so that you could detect when you're irrigating too much, when you're starting to leach in places where you don't want to. So that's kind of the high level response. I don't know if Sebastian would like to add to that. Might have lost Sebastian again. He's been having connectivity trouble.
Yes, with everyone working from home, All of Sacramento gets online at 8 o'clock in the morning, and the communications gets hard. Okay, we've got time, I think, for maybe one or two additional questions. Next question is, if I'm setting up a new large block and assuming relatively similar soil conditions, any suggestion for optimum block size? Sebastian, this is definitely for you.
I think he's still trying to get back on to the meeting. I mean, my take on this is that you know, there are a lot of factors that you have to take into account in terms of you know, probably, you know, your pumping capacity or your water source, things of that nature. So I mean, and that's, you know, Leif mentioned one of the things about having a trial and being able to have you know, our agronomist Sebastian come talk to you about your system. So you know, for the person who asked this question, I think it's hard for me to give a good answer without really seeing some of the particulars. And I'd encourage, you know, everyone with similar questions to reach out to us at WaterBit. I think you can hit the contact us on our webpage, and you know, we're happy to come take a look at your system and see what your needs might be and how we might help you answer those questions, as well as, you know, how the WaterBit solution can help you in the long term managing your field.
So we've got one more question here that we can answer, and then I think we'll wrap. Just the final question, and I think it's a great question, although I may not have a wonderful answer for it. The question is the cost for small farmers. How can we make the technology affordable for small and marginal farmers across India? And I wouldn't say just India. I think it's everywhere. Even here in California, where we have lots of high-value crops being grown by smaller growers that don't have the same scale as some of the larger operations. The cost of these types of systems is absolutely a challenge. And I think that it may end up that that's a little bit of a self-solving problem, just in the sense that like all technologies, as technologies are adopted and they're rolled out and they become more common, innovators, manufacturers, organizations that build these types of technologies are able to drive the costs down. We as an organization are focused on you know, driving the unit cost of devices down, and our philosophy has always been that if we can't get the cost of connecting devices in the field or connecting sensors to a precision irrigation system, then it won't scale for anyone. So we are definitely focused on, you know, driving unit costs down as quickly as we possibly can. And you know, I think that that is the holy grail. If we can get to the point where we can get the technology out at a very, very low cost point, then I think that will help growers who are operating in very small, you know, very small operations. You know, one of the benefits of using communication technology like we have is that you can share those resources across many, many growers. That helps deal with the cost. But it really just comes down to being able to design things that are more efficient and more effective, and able to be manufactured very, very inexpensively. And this, of course, all has to be done with the considerations for the fact that farming is a tough environment. It's a very difficult place to deploy technology, and much of the technology doesn't survive over the long term. So I know that that's not a direct answer, more directionally an answer, but I think that's where things are headed over the long run. I think with that, we will wrap it up. I want to thank everyone again for joining us today, and thank you for sticking with us through the entire time. If you have any specific questions that we didn't address, feel free to email them, and we will direct those offline. I'm happy to discuss any of these topics at a much greater level of depth. Again, thank you all for joining, and have a wonderful day.